Right, so welcome to this new session of API Community Belgium in collaboration with Axie. So today we're going to have the subject migrating an existing API management platform and moving towards external APIs using Gravity.io. I will not present the speakers. I think those people will be better in presenting themselves than I will be, so I will let that in a minute. A quick word on API Community Belgium, but I will not do it that long. So API Community Belgium is the independent user group for API enthusiasts in Belgium. And the rest we already know, so I will not repeat it. Just a kind of a timeline where we are. So we started in 2019, we launched the community. We were planning originally to do our first meetup in March 2020, but then a nice Chinese virus came that messed up a bit our plans, but lots of people their plans. So in April 2020, we started our first virtual meetup. That was also the format we did since then. And then as of this year, we try to do real meetups. That the community members can meet in person, and we are happy that at least some people are coming, but we start to see that still people like the online format and watch recording. So for those people going to watch this online, I hope you also are going to enjoy the content. And now we are here today, our third real meetup together with Axie, together with Gravity.io. So thanks for that. Yeah, just a bit of a recap. How can you find us? Our main website, that's apicommunity.be, where you find all the sessions, all the links. And of course, you also have our Meetup platform that you can reach to meet.apicommunity.be. And of course, for all the recordings, you can also find them on YouTube, on watch.apicommunity.be. And of course, we're also present on LinkedIn. And you can also reach out to us through Slack. Going to go quickly through it, but these are a bit the volunteers that make API Community BE happen, because we are a VZW, a non-profit, and today you find me and both here today as part of the community members. And a kind of a last thank to all the partners that make it happen. But today we have Axie, basically. Yeah. And now I'm going to give the floor to the presenters.
So, hi and welcome everybody, and really nice to get to see some new faces, especially meeting face-to-face here locally. So, I will start with a short introduction. So, my name is Tobias, and I work as an account director at Gravity. So, I work primarily with our customers in the Nordic region and in the Benelux region. And then I have my colleague Dorian.
Yeah. Vermandel, solution engineer at Gravity. So, here for the technical part, and you will hear from me at the very end. I will do the demonstration today.
Thank you, Dorian. So I thought I would start with the agenda on the topics that we will cover today. So first of all, I will give a brief introduction to Gravity, who are Gravity, and talking a little bit on our vision of API 3.0. Then we will have Steven from Axie, who will run a customer case on migrating between API platforms. And we will have a little bit more of an overview of the Gravity platform. After that, we will jump in and having a little bit more deeper and more technical part, focusing on service management ecosystems and primarily on a use case using a Kafka connector. We will also go through deployment models, technologies and architectures from a Gravity perspective. And then Dorian will wrap it up with a demo going through exciting use case. So if we start with who are Gravity, so Gravity is the most complete and downloaded open source platform for API management today. And I will just briefly go through a little bit of the background of the Gravity and also some key points that could be interesting to you guys as well. So Gravity originally was founded in France. We had 4 founders who were working with API management for some really large French companies, and they felt altogether that there was no platform on the market that really catered for the end-to-end life cycle when it comes to API management. So they started to develop their own platform, which is Gravity today. So they started with this in 2015, and when they started to share the Gravity platform in open source communities, they got a lot of interest very quickly, and they started in early 2016 get a lot of requests from customers that wanted to have support agreements and consultancy services related to Gravity. So then they felt that this is something they really should focus full time on, and they started Gravity in 2016. So we fast forward a couple of years to today's date. Gravity now has customers in 23 different countries globally, and we are approximately a bit over 100 people working at Gravity. We have our main bases in France, in Lille and Grenoble, and then we have our head office in London, and then also an office in Boulder in the US. One quite exciting number is the number we have in the top right corner of the slide, and it is 350,000 downloads and Docker pulls of our platform from August last month. So we have a lot of interest and a lot of open source users of our platform today. So if we jump over to the next slide and a little bit trying to visualize what we mean when we talk about API 3.0. So as you see on the slide here, there are a couple of waves. The first wave, what we call API 1.0, was primarily the growth of this genre, and it was primarily driven by standardization on top of first generation ESP tools. Then in 2015, we saw a new wave, what we call API 2.0. And here we have some early open source vendors that primarily cater to the change in the market with the movement to microservices and the rise of service mesh. What we see as API 3.0 and what is driving that is that we see our customers having more and more external use cases and broader use cases in their organizations, and that very much keeps on the need for standardization, the possibility to handle your APIs in a secure way, and primarily handle different type of protocols, both sync and async APIs. So that is a shift we see in the market, and something that we really try to cater to with our platform, with focus on ease of use, possibilities to have a real high focus on security, as well as handle multiple different types of protocols. So if we jump over to the Gravity platform, as you see on the slide, Gravity is based on a couple of different components and products. So in the left side of the slide, you see our open source edition, where we have the API management and the access management part. So if we start with the API management part, here we offer a full API management product, which has a management console. We have our gateways to handle and secure traffic, and we also have our developer portal and also an analytics dashboard where you can monitor and analyze your APIs. So we try to cater the whole API management part with management console, where you could add on your policies and your security measures. You have the possibility with the gateways to expose your APIs, and then you also in the platform can standardize documentation. You could easily publish your APIs in the developer portal, so it makes it very easy for the end consumer of the API to discover the right APIs, start to consume the API in an easy way, and both for the consumer and for you as an organization to monitor and analyze the performance and the traffic volumes of your APIs. Then we have access management, which is a full identity and access management offering. It is a standalone product, which some customers only use as a standalone product, but many of our customers use it together with our API management platform. And what access management enables you to do is to add more security and also a more seamless way to authenticate to your APIs. So access management gives you the possibility to federate different type of IDPs. It gives you the possibilities to offer OAuth 2, OpenID Connect. It gives the possibility to have single sign-on and multi-factor authentication. And we also have a lot of customers with consumer and consumer-facing applications using passwordless access through biometrics in your iPhone or equivalent products. If we then jump over to our enterprise offering, we have API Designer, which is API design first tool, which really focus on making it easy to design your APIs and enable people that maybe not are developers themselves to start to develop an API, and also helping you out with the standardization and automation of the documentation of the APIs. And here you could easily then push forward your APIs into your API management platform. And also AXI will have a demo on their tool a little bit later in this area, but this is an area we see growing very fast. More and more organizations want to collaborate between different types of stakeholders in the organization, and this type of design tools really enables better and more efficient collaboration between different entities in the organization. Then we have Alert Engine. Alert Engine is a product that will add a lot of value to your API management, especially when it comes to your monitoring part. So what Alert Engine offers is the possibilities to add alerts and notifications to your APIs. It could be, for example, security-based or, for example, performance-based. So just giving two examples, it could be that you have a consumer that has too many failed logins, or you could have an API that are not performing fast enough and is breaching your SLA with your partner or with your customer. And then you could easily set thresholds to send notifications and alerts. And you could send alerts through email, Slack connection, or using webhooks to send those notifications to an external monitoring service as well. And then we have Cockpit on top of everything. And Cockpit is a central management tool which enables multi-tenancy as well as giving you a unified dashboard of your Gravity installations. So if you have deployed API management, access management, and other products, maybe on-prem, maybe in the cloud, or in a hybrid structure, Cockpit will offer you one single interface to visualize your instances and giving you the possibilities to handle multi-tenancy and also health monitoring your instances. And as mentioned, when I walk through the Gravity platform, what we really try to do is to cater the whole API management lifecycle, from designing, develop, secure and expose, document, publish, discovery, consumption, monitoring, and alerting. We try to handle all these steps in our platform with the API Designer, with the API management component, with access management, alert engine, and then Cockpit, of course. So that was a short presentation of our platform, quite broad strokes, and we will get a little bit deeper later on. And now I will hand over to you, Steven.
Welcome everybody. My name is Janssens. I work as an integration architect for Axi. I have a background in software development and product development, but I shifted my focus to integration and API management, API design somewhere in 2016. I'm happy that I've been given the opportunity to give you some insights on this customer case where I've been working on migrating an existing API management platform towards Gravity.io. Let's first talk a little bit about the business context. The first question that pops in mind is, why on earth would somebody start a migration process if they already have an API management platform in place? Could it be that they were lacking functionality? No, that wasn't the case. Were there maybe some performance issues going on that they could not solve? That was neither the case. It was a case of the vendor dropping support for their lightweight API gateway, and the vendor offered a replacement which was more feature-rich, but also more expensive, 2.5 times more expensive than what they were paying before. And they have around 40 REST APIs that they are exposing through the gateway at present. It's a growing number, but they weren't willing to pay that amount of money for the API platform. And that's something that we see today in the market more and more with our customers as well, where certain cloud providers are raising their prices and customers start looking for other solutions. There was also a new business requirement to support an external consumer, but that could be covered with their lightweight API gateway as well. That was not the reason to migrate. But then we came along, we are the preferred integration partner, and we said, well, we think that we have a good replacement for you, function-wise and also price-wise. So we decided to offer them Gravity.io API management. Okay, migrating to Gravity, let's zoom in on that one. I first want to share with you the architecture that we have put in place at the customer side, and zoom in a little bit about the specialties that I think that are important in this design. It's a so-called hybrid deployment. The customer has an internal gateway that's here, deployed on its local area network, and you see the traditional management plane of an API gateway. You see the console. You have a management API here in between, a configuration database where all the configuration data from the APIs are stored. Then we have the gateway itself and an analytics database where all the log information and the metrics are stored, which are exposed through the management API in the console in the form of dashboards, predefined dashboards and dashboards that you can customize. We also have a portal, a developer portal, where the different API consumers can find the information, documentation about the APIs, and also self-subscribe to the APIs. What's important to note is that we have one internal gateway, one external gateway here in the demilitarized zone of the customer's network, but we only have one developer portal and one management plane. So that's the first thing I wanted to note. Another thing that is important to see here is also we're using a bridge gateway, or also called technical gateway. The production gateway, the internal production gateway, you see that it has a direct link to the configuration database, which in this case we are using a MongoDB. There are multiple different types of repositories possible with Gravity, but we decided to go for MongoDB. From a security point of view, we did not want to open a direct connection from the demilitarized zone into the local area network to the MongoDB. So what the bridge gateway does, it basically is a REST API that offers the configuration information out of the config database, and the production gateway, the external gateway, pulls that information, it pulls that information on a timely schedule into its own local memory. And that is an HTTP connection which is secured with mutual TLS. So we use client and server certificates on that connection. Another thing you see is, here we have a direct connection to the analytics database. The analytics database that we are using is Elasticsearch. So there is a direct connection through a native protocol from Elasticsearch, from the internal gateway to the analytics database. That is also a connection that we did not want to open inside the corporate firewall from outside. So what we have done is we have set up the external gateway to use file-based logging. And those files are, with a cron job, together with Logstash, loaded into the analytics database on a timely scale. So there is a slight delay on the metrics that are available in the management console, but that is okay for logging and for metrics purposes. What else is important here? What you can see also is that the external gateway has no direct connections to the internal backends. What we wanted to avoid was, or to lower the attack surface from outside. So otherwise, for each and every internal backend that we wanted to expose to the outside, we would have had to open some firewall ports to the inside. And that's something that the customer didn't want. So how did we solve that? We first deploy that API on the internal gateway. Then we do a different deployment of that same API, but the endpoint is not pointing to the internal backend, but is pointing towards the internal gateway. And that way we eliminate the use of multiple holes inside the corporate firewall.
Is there also mutual TLS used between both gateways, or?
No, the mutual TLS is not enforced on that. We could do that, but at present we are not doing it. But you can enable it. You can enable it on gateway level, but then it's for all API consumers. That's something you don't want. But you can also enforce it on API level itself. So if you want to do that for really sensitive data, for example, we can always decide to enforce that as a result. Yeah, that's it. Yeah, you see a local rate limiting database. That's also on MongoDB, but that's a temporary storage for rate limiting purposes. So there is no really sensitive data going on here. And something that I will tell later on, but I can just tell is here as well, is between the production gateway and the internal gateways, we are no longer using load balancers. The reason for that is that the Gravity gateway has built-in load balancing capabilities. So we decided to eliminate the F5 load balancer there in the architecture. So that was a benefit of using of migrating to Gravity in this case. Okay, let's go over the migration strategy, of the important things in the migration strategy. First thing that we did was set up the API management platform, the Gravity API management platform, next to the existing one. That was basically for business continuity. And by doing so, there was no big bang migration where we shut down the old platform and then hope for the best that everything was working well on the new platform. No, we could thoroughly test the new gateway, all the APIs that we deployed, test the consumers, and do it in a migration in a consumer by consumer fashion. Next, we published all existing APIs to the new Gravity APIM platform. There are 40 APIs, and the publication of the APIs is done by a central team at the customer. So that was it was easy to first publish all the APIs. It was just one team doing the effort, and then moving on and then migrating consumer per consumer. One thing that we wanted to eliminate is that there was no development effort involved in migrating consumers from the old platform into the new platform. Because if you have to go through a development cycle, you have to go through deployment, testing, finding the resources, and those development teams are working hard on new features, and migrating is not something that has high priority. So we wanted to eliminate the cost of doing extra development. They were using API keys for their security scheme. And since they were using that, together with a custom HTTP header, we configured this HTTP header, this custom HTTP header, also in Gravity. So the API keys security scheme also now uses the same header. So the only thing we had to do to move existing consumers to the new platform was just update two configuration values. One was the endpoint, pointing to the new API management platform. And the second thing was providing them with the new API key for their new subscription. And that was basically it. So that was very important, and that's something that helped us very much in a smooth migration for the consumers. Okay, caveats and lessons learned. API migration is a manual action. We have different API solutions on the market, and they all use their own proprietary storage system for storing their configuration, the API configuration information. You should invest in up-to-date API definition files. Swagger 2.0 or API 3.0 are the most common. And those two formats are also best supported by all the API management platform to kickstart your API creation with an import function. So Gravity also has that import function. So we updated some of their outdated open API specifications. It doubled up as updated documentation as well. So that was a win there too. And then imported it. And then when it was necessary for some APIs, manually added some request and response policies later on in the API design. API versioning. For API versioning, my recommendation here is to always use URI versioning. Use a part in your URL with a version in it, and not use other techniques like a custom HTTP header or the more standard one, the accept header. Why? Because not every API management platform will have support for those custom headers, and URI versioning will always be supported. It's just part of an endpoint. You can always be sure that it will work if you have to migrate to another platform. So that's a thing that we learned, and luckily most of their APIs were already using that versioning strategy. So for most of the APIs we did not have that much work. But that's a lesson learned for other customers, because migration might become more and more common in the next few years, I think. Yeah, metrics and logging information. That's a bit like the API configuration data. API configuration data is vendor specific. The same counts for logging and metrics information. So by moving to the Gravity platform, we lost that information. You could mitigate that by using a centralized logging solution, pushing your logs and your metrics also to a centralized logging solution and store that then in a more common format. So there is a possibility to bypass that, but in this specific case, they did not have that centralized logging setup, so they lost their consumption history, but they were fine by that. We did not have to export it or do anything and moving it and setting up a central logging system. But that's a thing to note. Reviewing the existing API management solution architecture. I was talking a bit earlier that you have a design from your previous platform. Look at it and decide from, do we need to keep all the components on it, or can we eliminate some other components that are no longer necessary? What does my new platform offer? And maybe I can eliminate, in this case, it was the load balancing feature and the load balancer that could be eliminated between the gateway and the backends. And then automation. If you recall the slide on, or the diagram of the architecture, you saw that the console and the developer portal were all using a management API. So Gravity, they're preaching API first, but they also designed their platform API first. That means that everything that you can do through the developer portal or through the management console, you can also do via REST API. So you could set up things to put it in DevOps or scripting. We use it to promote our APIs from one technical environment to another technical environment. And also for the enrollment of new consumers, we have a script where they can enroll, a new application is created, and they are subscribed to a new API and receive a new API key. That's it. And now give it to Dorian. Thank you.
So together we'll deep dive a bit more technically into the platform. And so the idea is I will show you some part of the platform, not everything. I will do a demonstration also that is related to our API 3.0 vision. And so the idea is you have there most of what we call the policies, that are the individual process that we use to put in place. I think you are all familiar with the term security, transformation, performance, and others. The idea, especially when you are doing a migration, is to be able to have most of these policies that are available on the shelf to be able to implement, to limit at the minimum the impact on the existing consumers, exactly what was existing previously. And so basically do a lift and shift of the existing APIs. So we have different categories. From the security, when we mostly know everything from the API key to connect to an external identity providers to put in place auth2 or OpenID connect flows to basically verify most of the time a GWT token. But it can be also useful to put in place IP filtering, to verify some HTTP signature, or for example, to do some role-based access control based, for example, it's on the scope you have directly integrating the tokens that are representing the consumer application, consumer end user. We have a lot of transformation policies as well. I will not go into the detail of each of them, but the idea is you have all the ability to modify everything from the responses and the requests of all the API traffic that is going on through the gateways of Gravity. So it can be useful for changing the headers, modifying the payloads with the assigned content policies as well. That is useful as well in terms of modernization. So to go further, a bit further than just a list and shift, is we are proposing some policies that can be helpful to convert some data format, for example, from XML to JSON, that can be also useful, for example, to use the REST to SOAP policies to kind of modernize some old SOAP web services to more modern RESTful APIs, and that's exactly what we are proposing. We have a cage policy in the performance to put in place cage directly at the gateway level, and we have a lot of other policies, some kind of classical, from the quota, the rate limit, the spike arrest, or the resource filtering. Some others are more interesting, I think. For example, we propose a mock policy that is especially useful when we are at the very beginning of the life cycle using the API designer to automatically mock the API from the specification. And so basically the Open API specification or Swagger specification. And this is also useful to go faster, as, for example, the consumer teams, that can be front-end teams, don't have to wait for the backend to be implemented to start calling the API and have the exact same structure of the messages they will receive. We can go further as well with some dynamic routing, HTTP callout, even having the ability to create some custom code using the Groovy or the JavaScript policy. And beside of that, what is interesting as well is all of these plugin policies. So yeah, I have spoiled a bit. Are seen as plugin from the platform, and so it's also possible to develop our own plugins to, for example, fulfill some kind of very homemade or specific use case. What is interesting is, so you can use all of that regarding a migration, but if you want to go further as well, this is what I will explain more in detail, and we will see in the demonstration. When you are choosing to move to an API management platform, that can be related to some cost saving, as we have seen in the previous example, but this can be also related to handling new subject and going further, for example, to fulfill the needs related to integration, related to new kind of architecture, so event-driven architecture. And so the idea is how to go further using what we call the SME at Gravity for service management ecosystem, to tackle these kind of new challenges that are related to new technologies, so not new technologies in terms of what is already used, but new technology in terms of how to replicate the experience we have with traditional APIs and API management to new ones. And so the idea behind the SME is to introduce, so as Steven has said, to our internal management API, a new one that is called the connector API that will be based, same thing as the policies and all the other part of our tools, so based on plugins, to be able to integrate between other protocols and to go further than what we support from years now, so HTTP protocol, to do RESTful APIs, SOAP web services, gRPC, WebSocket, and so on, and to go further. So for example, I will take the example of the Kafka plugin, and the idea of the Kafka plugin is to be able to, so at the gateway level, to do protocol mediation between some Kafka brokers on one side, and on the other side, what everybody knows well, and what is easy to integrate, especially with web and mobile applications that are so RESTful APIs or WebSocket, for example. And so be able, using some GET, POST policies or directly connecting to a WebSocket to so read and push messages into Kafka brokers. This will be exactly the same concept for the other kind of message protocols, can be MQP based or MQTT and so on. And so this is what you will see also in our roadmap in the future, when we will be releasing more and more plugins to handle these protocols. So at the end, the sum up is having one place to easily govern both traditional API and event-driven API to fulfill the needs of everything you already do with traditional API, security, transformation, visibility, subscription plan, analytics, and so on, but with event-driven. So just before going into the demonstration about that, I will talk a bit more about the technology and the deployment models we are proposing as well, because this is also important. And this can be something some kind of actors might look at when we are speaking about migration, because migration sometimes are limited by some new vendors that are only proposing SaaS solution. And so our point of view on that is to be very flexible and to go from full on-premise or private cloud deployment, where we can deploy basically all the components we have into the API management platform, access management platform, alert engine, to on the opposite have a full SaaS platform, and so Gravity can deploy and manage all the components of the platform for yourself, and basically this is a turnkey solution. You just have to connect and start to design your APIs. And in the middle, what is I think the most interesting approach, maybe both best of both worlds as well, with the hybrid one. So you had just before an example of a full on-premise hybrid one with a centralized management plane and some gateways in LAN and DMZ. But here in this example, you also have the ability to have the management plane that is hosted at Gravity, and so in SaaS, and so you don't have to install the console, the portal, and especially the databases. That might be the most complex point when we are talking about installation or upgrade and so on, while keeping the ability to deploy gateways where you need them. And so this can be gateways in SaaS as well, especially for external traffic when you have partners or consumers that are external. So you can sum up saying south to north traffic. And on the other side, keeping the ability to deploy also gateways on your own infrastructure or private cloud where you need them to still be able to manage internal traffic. And so east-west traffic between internal and internal producers and consumers. So when we are talking about the full on-premise deployment, or at least the customer-managed part of the hybrid one, the technology we are proposing are also a wide range for all the preferences, from installing directly using the binaries. And so our technology behind the scene are built on Java, and more precisely a Vertex framework for the one who knows, up to Docker containers. And we are, for example, providing some Docker Compose file to easily be able to test the platform locally, up to what is maybe the mostly asked today, the deployment on Kubernetes clusters using Helm chart we are also providing. So keep in mind also that Cockpit and API Designer are SaaS-only solutions. So these two are not something you can install by yourself, but most of the time this is not an issue as well, as there are web interfaces that are absolutely not related to the API traffic. So we'll not have any data related to the API that are deployed or the logs of the API that are deployed that will be visible into the cockpit or the API designer. So I will see through the demonstration. So the demonstration will be around this concept of API 3.0, and so I will demonstrate the Kafka plugin and how we can integrate into an event-driven architecture. The use case I've chosen for that is the financial fraud detection. And so the idea is we'll have some kind of users, so the good one and the bad ones. The bad ones will try to steal credit card. And the idea is how to be able to detect some kind of weird use cases when the same credit card is used for different location in a short amount of time. Or, for example, if we are doing way more to payment in a short amount of time. So this is equal free payment in 30 seconds. This is what I will demonstrate precisely. And all of that are so events for the transaction are something we can integrate directly with the API management platform using the Kafka plugin. So the idea is all the different transactions that will be done will be pushed as a RESTful call. So it will be a post call on a specific REST API that is exposed by the API management platform. So it will be on the context path will be /transactions. This will directly generate some messages that are pushed by the plugin into a topic, so a transaction topic. This will be used by KSQL DB that is here just to implement the logic of the detection. So this is where you will count the number of transactions we have for single users, for example, to detect if we have an anomaly. If we have one, this will be an anomaly, a fraud that is detected, pushed back into a topic that will be read by the Kafka plugin. And so again, we have the protocol mediation that is done by the plugin into the API management platform. This time not to use a RESTful API, but a WebSocket to have the full-time bi-directional exchange of data with a demo web application that is basically a dashboard to detect the transaction and to also show when we are detecting a fraud. The idea is we will keep the exact same user experience and platform for both traditional API and new kind of API, as we have here, that are related to event-driven. And so the idea is we can apply exactly what I think all of you already know, to apply authentication, authorization on the API, putting in place the different kind of security we have seen just before, from the API key to OAuth2 to verifying GWT token and so on, but also have this system of plan and subscription, so we'll be able to publish the API on the developer portal, and just as you have done before using a WSDL for SOAP web services or a Swagger and OpenAPI file for a RESTful API, you will be able to push So an async API specification file to document the API and to let the consumer discover the API, subscribe to the API, and so on. And obviously, all the different and 45 plus policies you have seen to put in place dynamic routing, traffic shaping, and go up to monitoring and alerting. This is exactly what you can do the same with that. So we'll switch to the demo. Let me know if it's too small for the people on the back. I can zoom a little bit. And the idea is, so just to show you a bit of the interfaces. So just on that, little disclaimer, if you can say, in the short amount of time we have, I will not have the opportunity to show you the whole platform. If you are interested, so we can talk after the presentation and I can show you specific part, but we have also a lot of videos directly on the website or on our YouTube channel as well. And especially you have a full demonstration of our platform that is 1.5 hours. So if you are interested into the API designer or how to properly put in place policies on APIs, you can go directly to this great video and you will have all details. So what you are seeing there is Cockpit. Just to explain a bit more what is my demo environment. So you have an organization that is Dorian Solution Engineer that is related to two technical environments. So you have a production and a development. And each of them are related to a specific API management and access management platform. So for the demonstration, we will use the API management platform I have deployed in development environment. So this is what you are seeing there. So this is one of the two user interfaces. This is the administration console, where I have the list of API I have deployed. And you can see that the hybrid Kafka demo API I have deployed there is exactly the same as the other APIs that are traditional RESTful APIs. The only difference is, so just to show you a bit the interfaces, you have obviously the details, you have the danger zone and the ability to start, stop the API, publish the API on the developer portal, this is already done. To manage the visibility as well, if you want to restrict the visibility and the usage of the API to some members and groups, this is something you can do directly there. You can manage the documentation with the pages, this is where I have imported my async API specification and so on, and obviously manage the plan and the subscription. You have a lot of other interfaces. I will not show you all of that today, but this is where you will find the design to apply the policies, the analytics to show the metrics and the dashboard, but also the logs, so call by call, the details of what happened at the platform level and the API management platform level, and so on. In the proxy, the only difference you have between a traditional API, a SOAP, basically using the HTTP protocol, and this one is on the endpoint part. And you can see here, the type of my backend is Kafka. And what you have there is not an HTTP URL pointing to SOAP web services or a RESTful API, but directly so here's the host and port of my Kafka broker. So that's the only difference. On the other side, just to show you rapidly as well, you have the developer portal, and if I go to the catalog and the APIs that are already published, I will find my hybrid demo Kafka API. And if I go to the documentation, here you will see, so not an Open API specification, but an async API specification with the server and the operations that are related to the transaction and the anomalies we will detect. So just to jump into the demonstration, these are the fake interfaces of the web application. On the left side, we have the interface that is representing the user that will generate a new transaction, and so do a post request onto the Gravity API management platform to create a new transaction. And on the right side, you have two different tables that are related to two WebSockets to get in real time the transaction and the detected fault. And so the idea, I will be very quickly on that, is if I generate, for example, too much transaction, let's say 3 in less than 30 seconds, it will automatically generate a new fraud and be detected. And so the idea behind that is, those are technically React web application that don't have by default the ability to talk directly to Kafka brokers. And on the other side, the technologies that are used don't have the ability as well to create the full experience with security, authentication, subscription, analytics, and so on. And so that's why we have in between the Gravity gateways with the Kafka plugin to be able to do that and to put in place this protocol mediation to be able to call directly the gateways using RESTful APIs or WebSockets. So that's it for my part, and if you have questions or more details, I can show you all of that after the presentation. So I will come back there, and I will give you the hand, Michiel. Yes, thanks. Thanks.
Hi, I'm Michiel. I'm solution architect at Axie. In this last session, I want to show you why we decided at Axie to create our own API modeling tool. The decision was taken late 2017 when we saw that people working at Axie had difficulties with the existing tooling which was available at the market that time. So agenda, why did we find the need for a new API modeling tool, and of course the solution what we created to handle the problems we found. If we looked at the current, or at the time being, the tooling which was available on the market, we could divide it in mainly 4 different categories. You had simply textual editors. You could use Visual Studio Code, for example, with some YAML syntax verification, which of course gives a very bad experience if you want to create an API. Second category is a category of tools which still need to be created in a textual way, but give a visual representation. Still a very bad user experience. Third category is the largest category of applications or tools which is available on the market. You can create an API by using visual forms and wizards, but still it has some issues which I will come back to later. The last category is a fully graphical environment where you can design the API and get an overview and have all the tools you need to maintain the API in a consistent way. Especially in 2017, there were very few tools which would do that. Okay. Beside of the different categories, we had a big different issue. All the available tooling was, and I think at this moment still is, very technical. It's really meant for people who understand REST and OpenAPI and so on. People with a business mind, functional people, really have difficulties in using those toolings, which often result in delaying the actual API design until the technical phase. Next to the fact that it's for a lot of people hard to create an API, it's often also difficult to discuss an existing API with the tooling which was available. APIs often grow into very large documents, which make it even harder. Relations are very difficult to see between different models, between the models and the REST endpoints and so on. And once again, for functional people who often have the knowledge, and especially in the beginning of a project, it's in their minds, it's very difficult to translate this into an API. Some examples of existing tooling. I think we all know the Swagger editor, which is a textual editor. You have to know the YAML structure, the syntax of an OpenAPI, which is hard for some people. You really have to know the syntax. If you make some mistakes, it's quite hard to find them. And you get only a list view of everything which is created. In a complex API, it's hard to see the relation between different types. Here in this example, I've used the Spotify API. We all know that Spotify handles about songs and authors and albums. It will be pretty easy to figure the different models together. But if you get a random or a complex API from a third party or from another part of the company, it might be way more difficult to see the relation between the different parts of that API. Another, it doesn't come through quite well, but another tool available on the market gives you the wizard and form-based functionality to create an API, but it's still very technical. Functional people won't be able to use this, and the overview is still very hard. If you want to see how album and artist and playlist are linked together, it's really hard with those kind of tools. Last category are the really graphical tooling, which was available on the market, but still it remains technical. It's still not always obvious to see how everything is related. If you want to create APIs, you still have to know everything about REST and so on. Okay, so we've seen that it's, or at least it was, very difficult to create APIs, to discuss about APIs with different parties. But as well with that tooling, it was very hard to make adjustments, to make evolutions to the APIs. It was really hard to rename, modify, move, remove certain parts, models of the API. And if the application helped you with it, in some cases, the API became inconsistent. For example, even here, as today, some of the more popular applications still fail in renaming models. After you rename an existing model in an API, you will get errors because it's still referenced with the old name in a different part of the API. And same issue with deleting an existing model. The model will be deleted, but it's still referenced in other parts of the API. So it's really an issue in order to create, maintain, and discuss in an efficient way APIs. So our conclusion was the current tooling isn't just efficient enough to help us create and develop in an efficient way our APIs. So we decided to create our own API modeler. Of course, it had to be graphical and very easy to use. We wanted it to be used in discussions, so we could discuss our own designs or designs of partners. It had to be usable for functional people, so with a high level, but as well we wanted to have a possibility to edit every last technical detail. So both functional people and technical people have to be able to work with it. It had to be wizard driven, it had to be very easy and self-explaining about how to create types of models and endpoints. And it had to be very easy to restructure, reorganize existing APIs. And of course, while doing that, your API has to be consistent all the time. We also implemented a full undo redo implementation, so if something didn't turn up the way you wanted, you could easily undo. So I'm going to divide the next part of the presentation in some different topics. First, we are going to see the graphical representation. I will show it. Well, the tools should be easy to discuss existing APIs. It's very hard to see here, it's a bit pity, but here we represent the same Spotify API we've seen in the earlier slides. So you have a visual representation of the API. You see the relation between the different objects. The arrows aren't really easy to see, but on a real screen you easily see the relations between the different models, and I don't know where, anyone knows where the pointer is?
Yeah, there's
On top? Yeah, well, here you even see that a model from a different API document is referenced. So it's really easy to see the different models and as well the endpoints which are related to a given model. So we wanted it to be very easy to create and link different models together. The details aren't coming through, but anyway, here we've got a blank document where we easily can invoke a wizard to create a new model. We've got some templating system in the application where we can define fields which should always be applied to a new entity. There are more things which can be applied in the templates, but I'm not going into detail in this brief session about the application. But we start with a template system. We can easily add fields to our model. We can specify all properties about our fields. For example, the name of an album or the available markets for that album, which is in this case an array of strings, for example. You can easily add additional properties which will be depending on the type you've chosen. In case of a string, you will be able to specify minimum length, maximum length, the normal stuff which you can define on an API. So we get an overview of the model to be created, and we can very easily create the model. We can create some additional ones such as artist and track, and then it's really simple to link the different models. For example, if you want to add an array of artists to the album, you just drag from artist to album, and you'll get an array of artists in our album model. Same goes for tracks. There are other ways of doing as well. You can add singletons, lists, and so on. Okay, if we added a fourth object or model, the Spotify object, which is a general type of model, we can easily let other models inherit from this model simply by dragging from, for example, artist to Spotify model, and our object will now inherit from that. Okay, I think this is an old version. Okay. So we can as well very easily create endpoints on the relation or on the models we've created. We can either let the application fully automatically create the endpoints. We can use suggestions which can be made by the application, or we can manually create them and fine-tune every last detail of an endpoint. In this case, when you invoke the wizard, it will detect the relations between the different models and give you a list of suggested endpoints which you might want to create. Just check the endpoints you want and apply them, and you get all the endpoints created automatically. So people without any technical knowledge, without any REST knowledge, can easily create an API. After creating them, you can see every detail of the REST endpoint, such as the name, the different arguments. You can simply add paging, or by clicking paging, you get the arguments needed for paging. They are all defined in the template, which I told before. A response object is automatically created with the response button. You can easily add other responses which are pre-configured. A path is automatically pre-configured, but everything can be manually adjusted as needed. Okay, something about consistency. So whenever we make a modification to an existing API, for example, here I want to delete the track model, we will be warned about usages of this model. It's referenced in a number of other models, such as, for example, album. The tracks field from album still refers to this track model. We can decide not to delete it, of course, or we can simply delete the model, which will result in deleting the referencing field, because otherwise you get an inconsistent API. Alternatively, you can also choose to link the existing field to a different type. So in any case, you still keep an up-to-date model, consistent model. In nearly any case, an API grows, and at a certain point it gets to the fact that it gets difficult to discuss, and so we want to restructure our API. We want to split it in different documents. Here I added a number of different models to the API, but we can see a number of models which are related to the user. So we want to transfer them to a new API document, and again, this is very easily done by a wizard. We just select the models we want to transfer, create a new model, and they will be transferred. Again, some detail is lost on the screen here, but you see that a number of models are removed, or they are moved to a different document, but those which are directly referenced by the models in this API document are still visible, so it's still very easy to see the coherence of the API. We've got a number of other models which are more general, so we can easily move them as well to a other document general, and then this way we get an API which is more focused on what's the intention of this part of the API. In this case, we want to have all information about the playlist and artist and so on, and we are less concerned in the other stuff. We've get an overview of the different API documents, the templates documents which I've discussed earlier, which can be edited. I can show you later on if you are interested. And we've got the 3 API documents, and if you, for example, go to the user document, you'll see that the models which were at the beginning of the demo in the Spotify document are now moved here. We still see references to other API documents, so in any case you have a coherent story about your API. Okay, so I see this is the last slide in this presentation. I'm still here after this session, and you can ask me about whatever you want. We did have a form which you could fill in, but I see it's lost. I've got it on my PC slide with that form. So we want to ask you for feedback, what you think about this application. So I'll show it on the screen, and then you can. It's just I think it's a Microsoft Office form or something like this.
QR code.
Yeah, QR code. You can scan. You just get to a page. You don't have to install anything, and it's only 2 minutes questionnaire. Okay, so that's everything for my demonstration.